Hi, in this project we will be building a deep learning model that is to be trained on DNA promoter dataset to understand if a person has the E. coli virus or not. We will then prepare our own very website that will be built using the Django framework and hosted on AWS. So let's get started. Now first I'm going to go through the contents of this project, which includes what exactly we are building, what technologies are we going to use, and what platforms will we be using to develop this project. Right now, I have segregated them onto four steps. That is, first the introduction, where you're going to understand what we are going to do in this project, then building the model, creating our own Django project, that is our website, and lastly, hosting the website on AWS. So in this project, we will be working on DNA dataset, which holds the information about a small part from the DNA encoded into four types of DNA molecules. When we say encoded, what happens is that the DNA consists of four types of molecules, as you can even see here. These are adenine, cytosine, guanine, and thymine. Now, these are proteins that you can find in the DNA, and with the combination of these proteins, the DNA molecule is formed. So we are going to specify them as A, C, G, and T, right? So what happens is that if we take a very small part of the DNA, you can see that these molecules are connected to each other, uh, having different combinations like AACG or ACGT. Now, I'm not that don't have as deep insight in this, but basically this is what happens, right? So we have the data set and we pre-process the data set into a more usable format and trained our MLP classifier model. Now, this model is based on neural net architecture and provides a very high performance with less training time. Then we create a Django project which will become our website base, which will be later hosted on AWS. Right. So moving forward, that is the building the model. Now MLP classifier stands for multi-layer perceptron classifier, which in the name itself suggests it's a neural network, right? But unlike other classification algorithms which sklearn provides, such as support vectors or naive-Bayes classifier, MLP classifier relies on an underlying neural network to perform the task of classification, right? But we will be, diving deeper into how the MLP classifier is performing the classification task and what's exactly happening under the hood after we have built and trained the model. So that would be maybe two videos ahead, I think, right? So next is creating the Django project. Now Django is a free and open sourced web application framework written in Python. It includes advanced functionality like authentication support, management and admin panels, contact forms, basically forms which takes input from the users and you can save that data into the database and so on. Then it also supports file upload system and more. In other words, if you were creating a website from scratch, you would need to develop these components by yourself. But by using this framework instead, these components are already built. You just need to configure them properly to match to your site. So basically, these components are built as functions or classes, and you just need to import those functions or create objects for those classes and start working with them. Now, the third part is hosting on AWS, right? So this is the last stage or step, I would say, in the process of building the project where we host the newly made website using the Django platform onto the AWS. And that's a little misleading. We will be using the EC2 instance, that is the T2 micro instance, for hosting the website and understand how exactly the virtual servers and the cloud system works. So with this completed, we would be able to access our website and run the model from anywhere across the internet. Cool. So with this, we can move on to the first part, that was building the model. Hi guys. So this is the first part, right, where we're going to build the model. And moving forward, let's first go to the first block where you can see that I've imported the drive from google.collab, right? So what does this do? Basically, to import any data, ac- actually to import any file from your drive to the Google Collaboratory, you have to mount that drive onto the Google Collaboratory. So what's happening here is that I'm calling the drive folder to be mounted onto this collaboratory so that I can access all the files and folders inside this drive directory, right? So this is very important because if you haven't done this, then you won't be able to call any files from your drive or save any file to your drive, right? So this is very important to do. And then the next thing is importing all the important libraries or functions that we would need to, build our build our model. So the first package is NumPy, right, which stands for Numerical Python. Now it is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Right. As we know that even though Python is very easy language to understand and write code in, but it is also a very heavy coding language as compared to, let's say, C or C++, right? So NumPy was created to ease up the load and also increase the efficiency when handling arrays. Okay, so using NumPy, mathematical and logical operations on arrays can be performed. Now, people who are already into machine learning or have dived into data science uh, and has worked on project, they would be pretty much knowledgeable about these libraries and why they're used. But on the for people who are actually not so much acquainted with these libraries, there are three basic libraries that are very much important: NumPy, Pandas, and Matplotlib. Now, each is used very specifically for handling the data, doing operations on the data, and projecting the data as graphs, right? So the next package, as you can see, is the Matplotlib, again a very important package. And now Matplotlib is used as a plotting library for the Python programming language and its numerical mathematical extensions in NumPy. It provides an object-oriented API for embedding plots into applications using general-purpose GUI toolkits like Tkinter or GTK, right? So next you can see is the Pandas library. So the Pandas library is a Python package providing fast, flexible, and expressive data structures designed to work with relational or labeled data, right? When we talk about relational or labeled data, we basically mean every data set that is not not in a format in the non-SQL part, right? Which means that there are going to be primary keys, there are going to be string data types, float data types, int data types, right? Uh, Not exact. It all the data set that would not be images, maybe videos, and so on, right? So that is what we mean by relational or labeled data. Now, Pandas is well suited for many different kinds of data, which includes tabular data or time series data set, right? For that. So next is the Seaborn library. Again, this is a library used for plotting graphs using data sets to understand and have more insight on the data, right? What data we are actually using. Let's say what the mode for a particular column or what's the mean for a particular column. All that can be plotted pretty easily in Seaborn and both Matplotlib. Right. Next is the sklearn neural network. So basically, we're calling our an MLP classifier, which is again, as I told you, a subset of neural network from the sklearn library. Now, this library pretty much everyone knows about, but still, this library is the hub of all the machine learning models that have been created, right? You can call any type of machine learning models that exist on this planet from this library. Now, it has also included some neural net libraries too, but this is, I think, a new addition. This was not present before. Uh, Next is again the classification report and accuracy score, just to have a metric to see if the model is performing good or bad, right? And then we have the train test split function again to create a batch of training and testing data from our data set. Now, as you can see, what I've done first is to call the data set, right? So what I've done is to call the data set from this particular URL. Right. So this promoter gene sequence dataset is actually a free sourced data which you can use to train your models or to even build insights from. But what we are doing is that from this dataset, it contains a lot of other columns too. We are just calling out the class ID and sequence columns, right? And then we are just giving that as parameters to read CSV so that we can call the CSV data onto our Google Collaboratory. And next you can see that I've used the head function with the parameter 10. So what exactly head does is that it prints the data, right? It actually prints the data set onto your terminal, and the parameter is exactly showcasing how many rows you want to print. As you can see, 10 rows are shown here. And in the dataset, as you can see, there's this class which is denoted by plus and minus. Minus is not shown here, but plus and minus. Then there's the ID. Now, I'm not going to explain what exactly ID is, but this is something redundant and we won't be needing this to train a model, right? Now, this is the most important thing, this here, right? So this is the sequence, and this is actually called a promoter sequence, where we could extract information if the person has some kind of disease or not, right? I would go into this in detail a little bit later. But moving forward, we have the data variable that has our data and dot shape. So when we call the dot shape, it gives you the dimensions of the data, right? The rows and columns. So we have 106 rows and 3 columns, as you can see here, in terms of columns, right? Next is data.dtypes. It gives you the object type, right? If it's an int, float, string, but as you can see here, it is object only. So we can convert that into strings, or we can convert that into int type or float type, and that's up to you. But I haven't done that because it is not exactly needed here, right? Then moving forward, uh, yeah, here you can see what I've done is that first I have just taken the classes column and put that into this classes variable here, right? And just use the head function. When we don't give any parameter, it takes 5 as the default parameter and prints 5 rows. But since that was done before, but here is the important thing. Now this class variable holding only the class values, right? The class column values. If you use the value counts function on it, it would provide you with the frequency of each category it was able to go through when going through the data set. What exactly I mean is that let's say that in a column there are 3 categories A, B, C. And so what this function does is that it would count the number of time A came inside the column, then it would count the number of time B came inside the column or occurred inside the column, then the number of times C came. So as you can see here, we have 53 uh, occurrence of plus class and 53 occurrence of minus class. Now, as I told you, our class had two categories, the plus and the minus, denoting the if a person has E. coli virus in him. It doesn't matter if it's live or dormant, but if it is, then we have the plus class to signify that, and if the person doesn't have E. coli virus, we have the minus class to signify that. And in the data set, we have 53, 53, that is 50% of both the classes, which is pretty good. Now, next what I'm doing is generating the DNA sequence. Well, not exactly DNA sequence, the promoter sequence, right? Since DNA is very long and this small sequence won't even compare to that. But the promoter sequence. So using the log function, I'm going through each and every object inside the column. That means I'm going to row 1 sequence, then row 2 sequence, row 3 sequence, and so on till 106 sequence. And I'm uh, creating a list out of it, right? I'm creating a list out of it. Then as you can see, I'm just calling out the last sequence that we have, and here you can see that the last sequence is this. But you can also notice one thing, that there is a tab, right? Slash t tab function and then slash again appended to each and every sequence. So we have to remove that. Right, we have to remove that and also prepare our data set in a manner which can be given as input to our model. So we would be doing that in the next video, right? From here. Okay, so in this video, we were going to start with pre-processing the data, right? And that was the first step we were going to do is remove the tab from each sequence, that is slash t, and then the next slash after it also. But before doing that, first let's understand why this data set is important and what this data set can help us do. So basically, as I told you, a promoter is a short region of DNA where transcription of gene and or a genome begins, right? So DNA promoter have been proven to be a primary cause for many human diseases, especially diabetes, cancer, or other diseases also. So therefore, classifying promoters has become an interesting problem and has also attracted a lot of attention, right? Sorry, attention of researchers in the bioinformatics field. Thus, we will be taking the DNA promoter sequence to see if a human has the E. coli virus or not. Right. So this sequence is not like just any small part of the DNA. This is a short region, right, from where the transcription of the gene by RNA begins. So this is actually a particular part where we have taken up this short sequence from the DNA, and we are processing on it to understand if the person has a disease or not. And in that too, we are classifying if the person has the E. coli virus or E. coli disease or not, right? So moving forward, what is happening here is that I have my sequence, right, using the enumerate. Yeah, there was a lag. So using the enumerate uh, function, what is happening is that there's a dictionary, not dictionary, but a tuple being created where uh, we have the first element as the number, the second element as the sequence. So let's say that I have two sequences, right? So enumerate sequence gives me a list of tuples that has 1 comma sequence 1. Then in the next tuple I have 2 comma sequence 2, right? So this is what is happening in enumerate. And what I'm doing is that I'm creating the list of sec. So in this, only one sequence is going to be present, right? Since we are using a for loop, and this is the list of sequences. So here, exactly a sequence of TTGC, okay, not this, but CCAA and so on will be present, right? So that will be present here. And when I convert that to list, what it gives me is a list of T, comma, T, comma, G, and so on, right? So each and now this string is actually converted into a list of chars, like characters. And here what I'm doing is that I'm looking for each and every character, and if it is not a slash t, I'm asking to append this character back into the list, since we are doing a list comprehension. So what happening is that I have a character in my nucleotide, let's say T, and I'm searching if this T is equal to slash T. That is the tab character. If it is, then we are not going to use, we are not going to keep that in our list. And if it is not, we are going to keep that in our list. And then what I'm doing is that I again have a list of characters, that is my sequence, and then I'm pending that into the nucleoids. Lastly, what I'm doing is I'm creating a dictionary out of it, where the key is the let's say the key is the index, since we are starting from 0, since enumerate starts from 0 to the length minus 1 of this sequence list here. So as you can see, if I uh, give the key as 0, I'm getting the first sequence, and here you can see that each and every character is being specified, but also with the class it has, right? And I will tell you why I have also used or input the class here. But you can see there's no tab, there's no slash, nothing here, right? So this is what we have done. Next, as you can see, is converting the dictionary into a data frame, right? Since Dick, not a great naming, uh, not a great name, but as you can see, this dictionary holds uh, all the sequence of characters, right? All the sequence of characters plus at last we have the class 2. So once I convert that into a data frame, here you can see that now the data frame has each and every column as my sequence, with the last column as my, okay, there's no, why is there no class? There should have been a class here. Maybe it got submerged in here or something. But I have all these sequences here, and as you can see, I have 5 rows and 106 columns here, right? So again, this is not exactly the format I want to have, because in this format, I still can't provide the dataset to the training model, since again, this is characters. We can't input characters into the model, right? So first I have to transpose it, right? So once I transpose this, my columns become the rows become the column, and then I'm going to have 106 rows, which again indicates that now each column is going to indicate each sequence, right? This is here not exactly the format where you can say that maybe one column, this column is indicating one sequence, or this column is indicating one sequence, right? But here you can say that the here you can see that there's only 57 uh, 58 columns, and the last column is showcasing the class, that is if the person has E. coli or not. Okay, and moving forward, yeah, so this is just renaming the 58th column, sorry, 58th column as the class column, right? So now we have the class here. So we have used the rename function that is specific to data frame or series objects. Next, we have used the copy function, and it has a parameter deep that is equal to true or false. Now, if we type in as false, what this would do is that this would create a temp variable that refers to df variable. But if we say deep is equal to true, then all of the data that df holds is going to be stored into the temp variable. So the temp variable won't be referencing to anything. It would already hold the same data, right? So if you have learned about references in C++, right, then using pointers, you would get, you would understand it properly what having deep is equal to true or false would do for temp variable. Now what I'm doing is I'm dropping the class the class column, because now I'm going to separate out my independent variable and the dependent variable, where the dependent variable is basically what we are going to predict, right? That is this class only. Yeah, so we have come to the most entertaining part of pre-processing, that is the one hot encoder. So I've just called the one hot encoder, right? And I have a parameter that is equal to ignore, which means that if you have encountered data which is totally unique and was not found anywhere else, then you can ignore it and move forward to the next data in the column or in the row, right? So we have the fit function, what happens is that you fit your data onto the one hot encoder, and it first understands about the data. Like here you can see that it has understood that in the first column there are four parameters, four categories. In the second there are four categories. In the third there are four categories, right? Since there are only four molecules A, C, G, T to denote the DNA sequence. So here, once you fit, the one hot encoder understands all the categories that are present inside the data set and how to transform that, right? So in the next, you can see that I have printed the categories it has understood from the data, and as you can see here, for each and every column uh, it has understood that there are only four categories, which is also correct. Next, we have the transform function of the one hot encoder, and with that I've used the to array. So first let's understand what this is doing. So what happens is that it has understood the categories after fit. Now it has to transform the data, meaning I have to somehow get the character or the string data into numerical data so that I can, input this new numerical data into the model. If I just scroll down a little, you can see that there are some new columns created, and here you can see that there is 0, 0 or 1, right? You can see zeros and ones. So I have converted the char data into numerical one. So in transform, what happens is that, let's say for the first column I had four categories, right? A, C, G, and T. So it would create four new columns for me and input zeros and ones. So how this is happening is that, let's say I have my column, right? It has, let's say I have my column. There's A, G, C, T, A. Okay, this has to be A, then again A, then G. Right. Let's say this is the column I have, and one hot encoder. I fit this data into one hot encoder, and the one hot encoder understands that, yeah, there are four categories: A, G, C, and T. So once it understands that, what happens is that that would create four new columns for us: column one, column two, column three, and column four. Right. So four new columns are created, and here, since we had A here, it would say that this is 1 and rest of them are 0. Then I have G here. So it says that it is 0. I have 1 here, then again zeros. Then I have, let's say, C and T. So it would give me 0, 0, 1, 0, and again 0, 0, 0, and 1. So what exactly is happening is that for the A here, it says that column 1 is to be 1. So whenever in this column from my previous data, one hot encoder gets a value A, it would say that in column 1 you have to send 1, the rest would be put as 0. Then in G, whenever the one hot encoder understands that the value in this column is G, it would say that the column 1 is supposed to be now 0, and then the column 2 is 1 and the rest would be 0. So each column represents a unique category that was found from my previous data set, right? So each column would define an unique category, and whenever in this previous data set it would get a particular category, it would send 1 into that respective column and then provide zeros to the rest of the column. So this is how I was able to convert my categorical plus character data into the numerical ones. So uh, as you might have known before, or I can just specify this here also, there are different methods, right? There are different methods to create categorical data into numerical data. One is one hot encoding, and second is label. Okay, not the best in writing, I know, but that is label. This is label encoding, encoding, right? So what happens in label encoding is that, let's say again I have four unique categories inside a column. So what this would label encoding would do is that it would give A as 1, G as 2, and this is such a shitty handwriting, but please bear with it. C as 3, 3, and T as 4. Actually, all the numbering starts from 0, but just for this example, right? So it would give A as 1, G as 2, C as 3, and T as 4. Okay, so in this column, now when I get my new data set, it would only create me a single column, right? Column new, that is new, column new, and for A it would provide me 1, then 2, then 3, then 4, then again 1 and 1 and 2, right? So this would be my new data. So this is another method where you can transform your categorical or character data into not exactly character string, any kind of data to numerical ones, right? But why we have used one hot encoding instead of label encoding? Since in label encoding there won't be a problem of increased or high dimensionality, right? Here one column created 4 new columns. Here only one column created 1 new column, right? So why didn't we use this one? Now the particular reason is that when we feed this using this categories, when we feed the new data into the training for the for training the model understands that, yeah, this is 1, this is 2, this is 3, and this is 4. Oh, this is 4, this is the biggest value. I have to prioritize, or I have to give this value more importance. So unintentionally, uh, t category will be given more importance just because this value is 4 here. Now we didn't specify that A is better than T or T is better than G, because again these are separate things, right? But the model will understand that this is valued 4, this is valued 1, so this means T is better than A. So it would try to train itself in that format, which is not good for us, right? and that is why we have used one hot encoding. So back onto the code. Now you can also see that I have saved my one hot encoder, and I've saved my one hot encoder, and here you can see here you can see that I've used pickle. So pickle is a library which helps us in storing our models, storing our uh, other uh, other informative things into a .pickle file, where we can just call this again anywhere else, and that would load all of that data or even models back onto the Python script. Yeah, so I have saved my encoder, and I will tell you why I have saved this later. Okay, so this is just commented out code to load my pickled file. So as you can see, there's a function that is pickle.load, and here I just give my address to the file, and it loads the file and all the information into my encoder variable. Yeah. So now you can see that I have 5 row. Okay. Yeah. So from this point, you have to jump back to, okay, you have to jump back to, yeah, you have to jump here, because I've also shown a different way of getting the, getting the values from character to numbers. As you can see here, I have used the get dummies function, right? Again, this is doing the same thing as one hot encoding. It is creating a data set that is from your okay, that is from your character or categorical data type into a numerical one, right? So you can skip this part, or you can even go forward and see which which way is the better way, going through one hot encoding or just using the get dummies function from the data frames, right? But the main thing is that after we have finalized the model, finalized the data that is into the one and zeros format, we now start off by creating our X and Y dataset, then creating our training and testing batches, which is again used through train test split function, right? I've just input my independent variables, my dependent variables, test size. That means that 25% of the data will be in the testing batch, and then my random state, that is if you want the data to be shuffled or not, right? I've kept that as 1 so that it remains same. So the next part is the MLP classifier. So I've instantiated that and given some parameters to it, but we would be going forward with this in the next video. Right, so from here we're going to see the MLP classifier in action, right? Now, as I told you, it takes certain parameters as input. So the first thing that you can see here is the hidden layer sizes, and you can see a tuple here. Now the hidden layer sizes, and in this parameter we can specify the number of layers and the number of nodes we want to have in the neural network, right? In this neural network. So each element in the tuple represents the number of nodes at the ith position of the layer, where I is the index for that tuple. Thus, the length of the tuple indicates the total number of hidden layers in the neural network. Now, basically, what this signifies is that this is the first layer for my neural net. This is the second layer. This is the third layer. And in the first layer, I have 150 nodes. In the second layer, I have 100 nodes. And in the third layer, I have 50 nodes, which are getting trained, right? And the next parameter is the max iteration. That is again the epochs, how many times you uh, have to train the model on the number of batches we have. Then we have the activation. That is the activation function for each of these layers. I've kept that as ReLU. My solver, again the solver is the optimization function, right? That is the optimization function, which is Adam. And lastly is the random state, which again says that when creating the batches of training data, shovel the data. Then we have the fit function where we are training the data, sorry, training the model. Yeah, training the model, that is X train and Y train, my independent training variables and my dependent training variable. And you can see that the score is 1, basically 100% accuracy. Ooh, cool. Anyways, we are then predicting, right? We are then predicting, and you can see that this is the predict function working, giving me a ypred variable that has the predicted values, and having the score on again testing. We can see that the value is 0.925, that is 92 point, I can say 92.6%. Again, pretty good accuracy, but you can see that there's a little overfitting happening here, right? There's 1 and there's 92.6, but still a pretty good value for testing, right? Then we have the classification report function, which takes in the parameter my y test and my predicted values, right? So here you can see that the precision is 1 for the 0th class and 0.83 for my 1 class, which means that the model is really predicting and giving off values that are relevant for the 0th class at 100% accuracy, but only at 83% accuracy for the 1. And when we say 1, I mean the plus class, that is the person has E. coli virus. You can see the recall is 0.88 and 1. Somehow the, oh yeah, another thing, the precision and recall usually have an inverse relation with each other. So you can see that the things have been reversed here. It is giving a recall of 1, right? And then recall of 0.88 for my 0, that is non-E. coli virus class. I have an F1 score of 0.94 and 91. Again, these are very good values. Okay, so these are just averages for both of these, right? What we want to have a look at is this here. Okay, but let me just give you an explanation of what precision and recall is if you have literally no clue, or if you have a very basic understanding of it, right? So basically, precision and recall are two numbers which together are used to evaluate the performance of the classification, right? Of the classification model of other models that are like information retrieval models, right? So precision is defined as the fraction of relevant instances among all retrieved instances. And similarly, recall, sometimes also called sensitivity, is the fraction of retrieved instances among all relevant instances. Now again, this might not have made it a little, this might not have made clear what precision and recall are. So basically, precision, let's say I have a bowl of stones, and I have a machine that is grabbing those stones, and these stones should be green in color, right? So let's say I have 3 green stones in my hand and 1 red one from the robot. So I would say that the precision is now 3 by 4, right? Because I wanted to see the fraction of relevant instances among all retrieved instances, right? And again, the precision is the opposite of that. Okay, even if this not had made clear what precision and recall is, I think you can once go and search what both of these uh, metrics are, and they might better be able to understand, be able to be able to make you understand what both of these are and why we use them, right? So next is importing the confusion matrix. Okay, this is another a very powerful graph, I would say, when you're trying to see how good the accuracy is, how good the prediction power is of your model, right? So you can just call this out from the metric classes, confusion matrix, and give it the input as ypred, which is the predictions of my model, and the y test, the actual values, right? So if you give this and create a heat map for it. Again, this is the SNS, that is Seaborn library. So if you create a heat map for it, you can see that there's now this is the true class and this is the not true one. So basically what is happening is that it was able to predict 15 true cases and 2 false cases. And in this case, it was able to predict 10 correct cases, right? So in heat map, you can understand where there were true positives and false positives, meaning that the value was true and your model predicted it as true, and false cases or false positives are where the value was actually true, but your model predicted it as false, right? So this is that. And another thing which is very important is going through the loss curve. That is building a loss curve for your model. And as you can see that for iterations, what was the loss? And you can see that around 25, 30, you can see that after 30, there was very little uh, decrease in the loss. So you, from this model, you can say that going till 50 iterations was a overkill. We could have stopped around 40 or 35. Yeah. So this is also important because what happens is that a lot of times we build models, right? Having a lot of epochs, and then later on, what happens is that we see that at one point the error or the rate of error of decreasing has already stopped. So the error or loss value is not decreasing at all. So going forward and training the model is not able to understand anything. So then your accuracy will also not increase. So you can see that after 35-40, the model has not actually understood anything and is retaining all the information. So we could have stopped at 40. It would have saved us some time and also hardware specs, right? Moving forward. Now this is the part where I'm saving my model also, right? So I've saved my an MLP model again as a pickle file, and using the pickle.dumps, what I'm doing is saving this file into the path I have specified, right? So this is my model and this is my file. I've just opened this and sending that model into that file there. So at this point, we can say that we have completed the first part, that is building the machine learning or deep learning model, I would say, right? The deep learning model. And then this code is just to test it out, right? As you can see, I've just taken this as my value. I've just again created my character list. And you can see that this character list is like this here. Then you can see that I've created a data frame for it and then just transposed my data. Again, you can see here that I have loaded my model, right? This is my deep learning model here. Oh, sorry, the encoder here, and transforming my data, test data, using the encoder. And this transformed data is now sent to the predict function of my model, and you can see that the value is 1 here, which means the positive class. That means that this person, whoever this pro, promoting or the promoter DNA sample belongs to, has E. coli virus, right? So with this, we have completed the first part, and moving forward, we would go to the next part, that is building our website using the Django framework. How exactly the MLP classifier is working, right? So we would be going forward and learning about how exactly that the MLP classifier is able to classify, and maybe there would be some mathematics that you might be having a hard time understanding. So even for that, what you can do is go directly to the sklearn MLP classifier docs, or you can maybe go forward and search it on YouTube, so they might have a more detailed explanation. But this is just to give you a brief about what the MLP classifier is doing under the hood, and to make you understand about some of the parameters that it takes. Okay, now first of all, we have neurons in our system, right? So uh, we have the MLP classifier, right? Classifier, which is the multi-layered perceptron classifier. And next, it has a lot of neurons in it, right? So let's say that I have a system of 3 neurons as my input layer. Now this one is my input layer. Then I have one hidden layer also. Again, we have three neurons in that. And then I have my output layer, that is the uh, having one neuron only. Okay, so now what happens is that you give your features here. Okay, you give your features here, and it actually it actually uh, computes. So the model actually takes the weighted sum, right? So these neurons calculate the weighted sum and then provide the output. So it would provide the output here, it would provide the output here, it would provide the output here. And similarly for this neuron and this neuron. Okay, so I have my bias here, which is input, and I have my bias here also, which is again input, but we would come on to that later. So first what happens is that I have my input to the hidden layer as, let's say, weight 1 for x1 feature plus weight 2 for x2 feature dot dot till weight nth for x nth feature. Since n is equal to 3 for us, we have 3 features, so that would be 3. Again, this is my weighted sum. Okay, this is my weighted sum that gets input into these neurons. And then okay, and then if let's say that this weighted sum is actually greater than beta, okay, that is our threshold value. Okay, if it is greater than beta, our threshold value, we will predict that the class is going to be 1. If this is not greater than uh, uh, beta value, that is a threshold value, we would predict that the class is actually 0. Okay, so this is how we are determining the classes, and these classes would be determined here. But then again, it would compute the weighted sum again and then come back to here. Okay, so then this bias here would be used with the new weighted sum to predict this class when we reach here. Okay, using the weighted sum method. So that is that, right? Now, okay, so let's say the model doesn't actually give us the satisfied output, right? Let's say that the class was actually 0, but we predicted the class to be 1. So what we do is that we make changes in the weight. Now we make changes in the weight, but how do we do that? Is that yeah, is that now to make changes in the weight, we use the learning function, learning parameter, that is the learning rate, right? This is my learning rate into I would say difference. Let's say it is a difference. Now what is d? I would just specify that in a minute. And then my input. Okay, this is like the list of all the features having x1, x2 and x3 for us. Okay, that is what is defined by x here. I know this is not the best handwriting, but please bear. And d here, d here is the y hat minus y. So my predicted value minus my actual value. Okay, So that is how exactly we're able to change the weight. Now, if the weight changes, then my this function, right, this expression here also changes, and I get a better value. And then I again see if it is bigger than the beta or the threshold value I have provided or not. And if it is, then 1 or else 0. So this is how classes change after multiple trainings, and we get a better accuracy as we move on, keep on going with more epochs, right? That is my iterations. So this is how exactly uh, we uh, we enhance or we hyperparameterize the model, right? We can change the learning rate, and with that we are able to change the weights. And when weights are changed, the this expression becomes more accurate to judge if we are getting the value bigger or smaller than beta, and simultaneously the class it is going to define, right? But another thing is that I've told you that weights are changed and the values we change to change the weights and so on. But how does this actually happens inside the model, right? So what happens is that now we have two methods. Okay, not two methods, but two processes happening when we are running a neural network. The first is feed forward. Okay, so that is going from left to right, left to right. We go to the input layer, then hidden layer, then more hidden layers, and finally our output layer. Okay, but let's say, okay, that is the feed forward process or direction. Now the second process is back propagating. Okay, so in back propagating we have the we go in the right to left direction. So we start from output layer, then go back into hidden layers and hidden layers and hidden layers. We reach the input layer. Once we are going back, what processes exactly are we doing? Right. So let me specify that here. Let me just build the. Let me just build the. Let me just build the structure once again. And this is the input layer again. One is the input layer, two is the hidden layer, and three is the output layer. Now, what happens is that once uh, we calculate the weighted sum, right? We calculate the weighted sum, we have some values with us, right? Which correspond to be an expression that would be greater or less than beta, right? So I have some weight, some value with me here, and what we do now is that we check if my y hat and y are similar or not. Okay, that is then to strength. So how much strength am I getting? Is it very low or is it very high? Right. So if the value for difference is very high, then we understand that yeah, model is not working satisfactory. We have to go back and change the weights. So how that is happening is that we use the output error to adjust the weights of input at the output layer. As I told you, we had the delta weight, we change in weight as uh, either the learning rate or it can be influenced by the difference. That is what we are looking at, right? Difference. And my feature. feature. So this is the second parameter through which the model itself is able to take the weight, right? So when we talk about bias and wave at the start, when the model was just built, no, we didn't go from left to right and did no calculation whatsoever. Then the weights are randomly instantiated, and once we reach this point, the output layer point, for the first time, then we go back start updating the weights again and again through the difference. Right? Difference helps us in updating the weight. What happens is that we go back from output layer to hidden layer,
we tell that the weight used in these here in this area, we reach from hidden to output the left to right process. Then we had some weights. Now you have to change those weights according to what I am telling you now. So then we change the weights again. Then we go from hidden to inferior. Now the weights that were used before again weighted. Then we realize that, oh, we reached the first layer. Now we again have to move forward to see if these new weights are actually predicting better as just before. So we again go from here using the new weight, then we again go from hidden layer to next layer using the new weight that we had find just now. Then we see the D. When I say D, I mean the difference. Then we see the difference and understand that, oh, this time the difference was low, right? We can even go lower. So we again go back. This process of going forward and backward is in the cycle, and the epoch that we define is nothing but the number of times this cycle has to run, right? So this is how when each cycle runs, this and model is built correctly and data was also pre-processed correctly. We get we get a situation where after each cycle or after each epoch, we're getting a little better accuracy and a little lesser loss. That loss is less, right? So lesser loss, and the model is getting better and better in accuracy, in terms of accuracy. And lastly, we're able to predict uh, better accuracy the classes for our data, right? So this is how exactly the NLP classifier works. Now the next thing that I'm going to tell you about are the parameters in the code, parameters in the code, right? So parameters in the code is when you inserted the MLP classifier class, you have some parameters with you. First is the hidden layer. This is the first parameter. Now this takes a parameter of the number of layers you want in your classifier to have. Like this can be the first input layer, then the hidden layer, again hidden layer, and so on. This last one is your output layer, right? So the number of layers you want to have, and then the next number is, okay, this is actually a, like, you have your explainer, one explainer, right? So first is the number of layers. Next is your next is your next is your the activation function, right? So the activation function that you have to uh, use in each of the layers, that is defined here, right? That is defined here. Okay. So the length of the tuple indicates the total number of hidden layers in the neural network and the number of, okay, yeah. So see, this is the number of, okay, sorry, this was not the number of layers. This was the number of neurons you will have in one layer. Basically, you have here X neurons in your first layer. And if you have Y, then you will say that there are Y neurons in the second layer. And then you type it as Z, then we have Z number of neurons in our third layer. And this model will have only three layers since there's only three elements in this file. Right? So this is how exactly we are finding how many layers and how many neurons we want in each layer. Right? Sorry, I got confused with it. Then the next thing is max duration. Now that is max duration. Right. This is the next parameter. Okay, this is nothing but epoch, number of times you want the cycle to work. Okay. Then is the activation. Right. The activation. Now activation is the activation function you want to use. Do you want to use ReLU? You want to use Sigmoid? You want to use your custom made? You can just use that here. these are the there are even more, but they are not actually. Uh, you can use them, but unless you have knowledge about them and know how to actually use them to even increase the accuracy of the model, I would suggest that these stay as the default values. Okay. So with this, we have also completed how the MLP classifier works, and next we would again move on to the Django application.
Hi guys. So this is the second part where we're going to develop a website using the Django framework. Okay. So before moving forward and understanding what we have done in the code, let's first know more about Django itself. Now Django is a free and open source web application framework written in Python. Now this framework is actually nothing more than a collection of modules that makes development pretty much easier. They're a group of they are grouped together actually and also allow you to create applications or websites from an existing source instead of working from scratch, which basically means that you don't have to write your code from scratch about each and every feature that you have to implement in your website. Django already provides you with the base code onto which you can append more and create more functionality on top of the Django base website that it provides you, right? So, and this is how website, even simply ones, are designed by a single person and can still include advanced functionality like authentication support, management and admin panels, contact forms, uploading files, supports for upload and downloads, and much more functionalities. So in other words, if we were creating a website from scratch, you would have to develop all these components that I just specified before, right? You have to build each and every thing by yourself. But in Django, all of that has been handled by different modules or sub packages, and you just have to call them and use the functionality itself. So Django has a model template views architectural system that keeps in mind the requirements of front-end and database management for a developer. Right. So I would talk more about what is this model template views architectural system in a bit. Okay. So now moving forward, let's first see how to instantiate a Django project, right? But note, you don't have to run all the commands that I'm going to tell you right now because this is an already created project, right? So when I say project or Django project, that is just the base website that Django provides you, onto which you can code and append more, right? So first, while working with this project, right, as you can see from my screen, it has a my site directory, then another my site directory inside that, and a polls directory. Now both of these are different, and I will tell you how in just a bit. But first, just create a virtual environment for your project, right? For this Django project. Now, if you're using PyCharm like myself, what you can do is just go to the files, click on settings. Once you click on settings, a pop-up will open where you have to go to the project interpreter, right? So in your project here, since I have called this project as DNA sequence for E. coli, so that is the project name. Then inside that, there's a project interpreter. You click on that, and here you would see uh, all the virtual environments you have built, right? You can click on show all, and what you have to do is just click on the settings button here and click on add. So once you click on this, it would create a new environment for you. You can choose the base interpreter, that is the Python version that you want to use. Since I have 2 3 versions with me, okay, not from here, but from here you can choose all the Python versions you have and specify the one you want to use for this project, and just create your virtual environment, name it, right? So you can do that. Since I've already done this, I won't be doing this. As you can see, my virtual environment is named E. coli VNV, and it has all of these packages, right? So moving forward, once you have created the virtual environment, you have to install Django version 3.2.0. So basically what you would write in your command line is just pip or pip3 install Django 3.2.0, right? So if you would run this command, it would install the Django package and the version 3.2.0, and that is what we are using for this project. Okay. So once you have done that, the next step what I have done, but you don't have to do, is create a project. Now for that, you have this command here, Django-admin start project, and then the name of the project, which I have named as my site, right? So this is the project. Now once you run this command here, then this my site directory here is instantiated, and with that this sub my site directory also gets instantiated with settings, URLs, and VSGI Python files, right? I will tell you what these files are and why Django uses them, right? So once you have created your project, you have to create an app. Now, just like I told you, this my site directory and this polls directory have different functionalities. Now this my site directory holds the files which helps us in configuring our Django project, and this polls directory here, which is also called apps, is is to add on more functionality to the Django website, right? Let's say that I want to have file system support, or I want to have let's say to embed maybe a picture, or to embed something into your website. Then you create these apps and bring on those functionality, basically code those functionality inside here, right, in our views.py. So for that, to create the app, we would have to run this command, python manage.py. Now manage.py is a file that is provided by Django itself, which helps in running all these commands that are specific to Django and makes it easier for users to instantiate stuffs in Django only. Okay, so that is the command start app, and then the app name, which I have given as polls. You can even go to the Django docs, and if this has not been a really in-depth understanding, you haven't get a very good understanding of what we are doing right here, you can just even go to the docs, and they can also provide you with the same or similar information about how you can start an app, how you can start a project, what are the difference between those, right? So once we have also created the app for our project, the next thing is setting up the settings.py file. Now, as I told you, these files here, right? These files here are uh, files which helps us configure our Django project as to how the project should perform, how the website should interact with other applications, right? All of that is being handled here. So moving on to settings.py file. Now, as you can see, there are a lot of different variables created here, right? Middleware, templates, database, cache, authentication, right? So here, all of the uh, configuration part is done here, right? So Django provides you with a secret key using which you can also perform specific functionalities that Django provides a user to handle his or her project, right? So that is the key here. Now what I've done is that I've also created a .env file, which I've seen a lot of people not do. So what env file is actually a secret document which holds all the very personal information about your project inside it. And what you do is, you, rather than specifying each and every like secret key or the password to your database, password to some other site, right, all of that is actually set up inside this, and you just call that out into your settings.py file. So how this helps us is that, let's say somehow a person was able to uh, hack your server and go into your code, right? So he still wouldn't be able to get the key here from which he can, perform even more personal attacks on you. But from here, you can just simply say that, yeah, this is the key, and he wouldn't be able to see the key. And if he doesn't get the key, he can't do much about it, right? So this is why a .env file is very much preferred, especially if we are working with remote servers, right? This is very much preferred. So what you do is in the env file, you just create a variable and specify the value. Then what you do is just call that variable wherever you have to specify those values, right? Like secret keys to be specified here. So I just called the Django key variable. So for that, we use the .env package and load.env function. So what you do is just load the .env, which basically calls all the variables and its values. Then you can just call off the values using the keys here, right? Using the environ.get, and as we know, get is used for calling out values from dictionary keys, right? So that is what we are doing here. Now, there are a lot of settings and a lot of variables that we don't really have to understand to work with Django right now. At least in the basics part, we don't have to get to know much about them, right? So, but this is important. So, whichever I'm going through are important variables, which helps us in configuring even the basics for Django websites, right? So, first is the allowed host. We will go over both of these later, right? But first, let's just understand that this is the local host ID. And if you have specified this here, you would be able to run your Django website uh, locally, I mean, in your machine, right? So what happens is that once you instantiate your Django project using the commands I specified here in the steps part, this localhost is an empty array, right? But once you start configuring things, when you start working on the project, it's better to specify the allowed host inside the allowed host variable. Okay. Now these two are actually the DNS and IP of the AWS, right? Of the AWS, which we would be setting up later. So I would come on to this part then only. Next is the installed apps. So here you can see that there's an admin app, there's an authentication app, there's a content type app, there's a sessions app, message app, right? So all these apps are actually pre-built in Django, and these helps us actually to use the functionalities like file support system or authentication, right? So we don't have to code from scratch, but we can directly use these apps and call out their functions to have the functionality. Okay. So, but one thing to note is that we do have to include all the apps that we have created. So we have created the polls app, so we have to specify it here so that Django knows that, yeah, there's a user build app and I do have to integrate it into my Django website and use it and use its functionalities also. Okay. So again, middleware, we won't be going over this right now, but you can again see here that there are middlewares that are automatically handling things. There's session middleware, there's a CSRF view middleware. If you have worked a little in the front end part, you do know why CSRF tokens or why CSRF is needed, right? So there's an authentication middleware also. There's other middleware, or you can also create your own middlewares, but again, that's very advanced stuff right now. Next is the templates. Okay, so this is a term we have also heard about before too. Now, templates is, as I told you, the part of the model templates views architectural system, and templates define the HTML, the basic front end that we require and that is seen by the user, right? So when we go on a website, we see the page, right? So that is what we mean by templates. So templates are those HTML files that we serve when a user requests onto the URL, and then he is able to see the page. That page is uh, in technical terms called templates in Django. Okay, so again, if you have just instantiated, this directory part will be empty, so you have to tell Django that my templates would be in a folder named template and its location would be here. So the base directory is predefined. You just have to write base directory slash template, so it would be able to understand where templates are present in your website. I mean in the code, right? As you can see there, there's a template files here, right? So that is that. Next, we go to the databases, right? So this is the most amazing part about Django, that Django already provides you with a SQLite 3 database pre-built in the with the Django package, right? So you don't have to create your own different databases. But most people, what they do is they actually don't use the inbuilt version if they have to work with a lot of data. What they do is they connect a separate application like MySQL or Postgres with the Django website. So in this database variable, we then specify different settings with the host name, with the port they would be using, with the username and password. But for now, since we don't have to really keep the data anywhere, we're just using the database that is pre-built with Django. Next is the cache system, right? So Django also provides you with settings um, that helps you in making custom defined caches, like how they're going to work and till when they have to keep the cache and stuff like that, right? So for now, you just have to know that in the backend, we're going to use the low memory cache, right? And we just have to name this cache system so that we can call that out. And for that, we have just named it as unique snowflake, and which is specified by the location. Okay. Lastly, okay, so this is just the time zones, and you can just change it for your own if you're in some other country or if you have a different time zone, right? And just change that for your own purposes, because if let's say you're setting up a database that takes in time, it is going to take the UTC time zone, right? Uh, okay, so yeah, we can move forward right now, and let's just jump back to the apps. The model views template architectural system that I talked about would be pretty much highlighted here only, right? So how this is highlighted is that there's a models file, there's a views file, and then there's a template folder which holds the index.html. Now what happens is that the views is actually the backend system where all the calls are made, where all the data handling is taken care of, and any backend, not any, but many of the backend functionalities is actually handled in the views. You code here so that your website works with the functionality that you had in mind, right? So what happens is that you create a function, you pass on the request as a parameter, right? And then you create the functionality inside that function. And lastly, you return a render function which renders the HTML page. As you can see here, I have specified the HTML page and I have also specified the response, which I will be talking about later. So what happens is that, uh, okay, no, yeah. So what happens is that first you create your function, you call the HTML page. Now, this understands that you have to call the HTML page, so it serves this page to you. Okay, but how does Django understand that I have, whenever this function is called, I have to render this HTML page? I mean, we haven't specified any URL, right? So that is taken care by the urls.py file. So what you do is you create your path. Now, this path would be the local host, that is 127.0.0.1 slash 8000 port. Now Django has a default port of 8000 slash home. Now if I go onto this location or onto this URL, this URL's part will understand that, oh, we have just accessed this URL, so I have to call the handler function. right? I have to call the handler function. So in views, it understands that, oh, handler function has been called right now. So it would do the functionality here, and then it would render the HTML page, right? So now the whole cycle has been created where you go to the URL, you hit the URL, you understand that this function has to be called, and then this function understands that I have to render this page. So on the server, or sorry, on the browser, you see the index.html page, right? So this is how it's working right now. And but this is still the views and template part. How the models work? So the models are actually the files where you create your database, right? All the tables that you want, and to store all the data in those models or tables, right? They are the same thing. So in views, what happens is that once you're doing your functionality, you usually uh, make changes in your models, like you set up your data inside some tables, you have to retrieve your data from those tables. So that is again handled inside the function. So this is how the model views template architectural system is working inside Django, right? But since again we are not exactly storing any data inside the tables, we would not be using the models.py file. Okay. Now, lastly, to the response or the context part. So this is actually called a context, right? What happens is that, let's say I have rendered my HTML page and I have just input some data. Now that data has come here, okay? That data has come here inside this function and it has been processed and we get the results. So how do I send the results back to the front end so that the user can see what the results are? That is through context, okay? That is through context. And what we do is we just create a dictionary where we name key as response and send back our result as the value here. Okay, so in index.html, I have created a forms, right? A forms that is taking the input, right? The input as the thing that we want to predict about, and then we get the results back. That is the response. Okay, so here you can see that I've created a forms with method post and action and end type. Now this is important part because we would be creating forms and we also need, actually this is much more important when you work with file system, but you can even use this right now. So we have to input the CSRF token, right? So that there's no, so that the HTML page is able to validate the CSRF, sorry, right? Next is just to input. So you have an input function here that is taking the input, your promoter sequence here, right? I've just given this as example so that you don't have to again type and type and type to test your model, right? So this is for that. And then you have the submit button here, right? The submit button here, and okay, the submit button here, magic. And then there's the class search button, which is again used by the CSS. There's the submit return, and once you submit, you get your results in the views part after processing, and that uh, result is sent back in the term in the form of response, right? So you have the response here. Now this is how the project is working. We have already configured how the project should work, right? So once we have done that, for you, what you have to do is you have to actually first run another command, which I think I didn't specify before, right? Okay, I have specified. So you have to run this command first, python manager.py migrate. Now this command actually helps in instantiating all the tables that you have created and Django have created. So Django again already creates some tables for its own reference, and then you, maybe if you are creating more tables in the models.py, all of that has to be, created. Actually you have just coded now, but it is not created anywhere. You have to create those tables into your database, and for that you have to run this command, manage.py migrate. So once you run this command, uh, you would see that all the tables that you coded and Django has already is instantiated in your database, right? So once that is also completed, you can then move forward with python manage.py run server. Now this is the command to run your Django website locally. right? So if I type in python manage.py run server, so if I just run this command, it would just check up your code once, and if it finds no fault in it, it would provide you with the localhost URL, right? So once that is shown here, we can move forward to see how the site looks like. See, it's doing the performing system checks and all. Now this would take different amount of time on different machines. My machine is not that powerful, but okay, yeah. So it also provides you with warnings. Also, you can ignore that or you can fix that. That's up to you. And then you just click on the URL that it provides, and so it would give you a page not found. And there are two reasons for that. Uh, okay, from even here you can understand that why we have got this page not found, because in the URLs for the Django, it can only see that for slash admin slash and slash home slash. Only these two URLs are present in my Django project, which tells you about, yeah, on these URLs you might get some front end data, but except that you would only get this page not found because there's no HTML page associated with the base URL, that is localhost colon 8000 port. So if I go on home now, you can see that the page is loaded here, right? You can see the page is loaded. Now if I just type in my sequence here, again the sequence should be of the same length because the promoter sequence is of a specific length, right? And even the model is trained on a specific length sequence code. So let's say I've just put that here and I click on submit. Now you can see that the value is false, that this person who's a promoter gene we just a promoter gene sequence we just put in our input has doesn't has E. coli, right? So this is how we were able to build the project and we were able to configure it and lastly learn how the project is exactly working. Okay, now one last thing that I have not included right now, but we can just go and look at the code once. Now just to close your or to stop the server from running, you can just do control C and it would stop, and again run your command, that is python-py run server, to again restart the server. Okay, so in views I've created the handler function. This is the function that is calling my index.html page which was just now served on the browser. But there's another function, that is the predicting function. Now this is where I'm actually loading my encoder file, as you can see here, right? I've loaded my encoder file here, and you can also see that I have a model, right? A model variable, but model was not defined anywhere. We have actually imported the model from sustain. Now what I've done in sustain is that I've used the catch system, which means that let's say I have started my server, right? I have started my server, and what happens is that the model gets loaded. But if let's say I have to refresh my page, right? I have to refresh my page, then again the model will load because after each refresh, Django sees that if there is any changes in view or not. So it runs the view code again and again. So that many times that you refresh, that many times views will again run. Okay, but we don't want that because if we do that, then both the models, the encoder file and the other file that has my uh, neural net model will again and again load. Now this takes time and it slows down the website also. So what I've done is I've kept this as itself in the views only because this was just a, I don't know, 50 60 KB file, so it doesn't actually take much time to load. But the model was a little big. So what I did was I created a catch system where once the server is running, it would send your model into the cache so that whenever we refresh the page, it doesn't reload the whole model again. It stays in cache and it just calls from the cache, right? So in this way, the models won't be loaded again and again, and we can pretty much have a smoother and much faster website with us. Okay, so this is what I've done here. Now, what you have to do is actually create a cache key, which is unique for the model that we have to cache. And what we do is we just call the model, load the model, and then just set the cache key. And what happens is that once we have done this, the cache key is now a valid key. Then the next time cache has to work, it would just search for this cache key model, cache key, and call the model itself, right? So this is how it is accessing specific data in your cache. So with this, we have completed the second part, that was building our website using the Django framework. And next we would be first working on some files that we have to create and then move on to AWS for hosting this website. Hi, so this would be the third part, I guess. And here we would be hosting our web application that is built on Django framework, using Django framework onto AWS, using the EC2 instance, right? The EC2 services. Now, before moving forward to the console, the AWS console, there are two, three things to know about. Okay. Now, the first thing is that you have to create a requirements.txt file. Now, what does this mean is that you have to create a file that has listed out all the dependencies for your project or all the packages that you have used with the versions for that. Now, you don't have to create this manually. There's a command for that, which is pip freeze requirements.txt or whatever you want to name the file, right? It can be anything like example. So with this, it would create a requirements.txt file inside the directory you are in your command line. Okay, so with this you would get a txt file, something like this, right? So this is required because when we are going to set up our AWS server, we would need this list to download all the dependencies so that we can work on the, or basically run the website smoothly, since all of these require these dependencies are required by the project, right? So uh, this is the requirements.txt file, and once this has been instantiated, we can move forward to the AWS console, right? Let me just okay, so this is that, and then we have the AWS management console, right? So what you can do is just create a new account, or if you already have one, just log in into that. And one thing to note is that since I'm in India, you have to choose the Mumbai servers, right? Or you can just use any server you want to, but I would prefer if you choose the server that is closer to you, right? Because they have a lot different functionalities working on it, and they have stuff like how much requests are being issued onto each server, and when there's a lot of, they provide extra power to it. When there's less, they provide less power to it. So if you're working on a different region, then it might create, or it might slow down the server you are using a little bit for different time zones. Okay, next thing is just search EC2 here, right? Just search EC2 here, and there you can see all the services, the features it provides, right? So just go to the EC2, click on the EC2 virtual server in the cloud option. So once it has loaded, it would show you a page or where your instances are specified. Now, if you haven't created any instances, then it wouldn't show any list of instances here. It would be empty, and there would be an option of launch instance onto the top right side. Now, for hosting, we will be using AWS services, right? So EC2 is actually Amazon Elastic Compute Cloud Service, right? That provides a scalable computing capacity in the AWS cloud. Now, EC2 provides you with a lot of features. I would be mentioning some of the ones that we are going to use, right? So first of all, again, it's a virtual computing environment, and it is also known as instances, right? We have different instances like T2, T3, T2 micro, right? Now we already get pre-configured templates from Amazon, known as the Amazon Machine Images (AMIs), which I would be showing you in just a little while. Then we have various configurations for CPU, memory, and storage also. Again, different instances have different capacities in terms of, again, storage, memory, and CPU power. We also get secure login, right? We can log on to our AWS server remotely too, and it is uh, a very secure connection. Now we get storage volumes also for temporary data, and we also get persistent storage volumes. Now this is the permanent one, not the temporary ones, which you can use with your EC2 instances, and you can store those data using the Amazon Elastic Block Store, also known as EBS volumes, right? So you can do that. And with that, we also get static IP4 addresses for dynamic cloud computing. And these, again, this will be highlighted whenever we go on to those parts. But these are things that you should know about your instance, about the services that we are using. Okay, now before we start, we do need to do two things. First is download the required softwares, and the second thing is learn more about some of the terms that are important to configure your server in the AWS. Okay, so the software that you need to install are PuTTY, right? So if I just click on PuTTY, so it already shows PuTTY download Windows 10. So you just have to do that. This is the link for that. Download PuTTY. Again, it's a free software. So you can download PuTTY. Then there's a PuTTY Gen software. Right, there's a PuTTY Gen software. You have to install that also. Again, I will tell you why and what these softwares help us in doing. Right. So this is the PuTTY Gen. Next, and the last one is WinSCP. Okay. So the last software would be WinSAP. So you have to install all of these before you launch your instances, and I will tell you why. So this is WinSAP, right? Now you got once you get your all of the all of the softwares, then come back to your AWS console, click on launch instance inside your EC2, right? So now here you can see there are some of the steps to launch your instance, right? You can see that the first step is to choose an Amazon machine image. And about this, I just talked that this is the pre-configured templates for your instances, right? It has the package, the bits you need for your server, the operating system, and additional software that you would require. So all of that is pre-configured, and it has been differentiated on the basis of different operating systems and additional environments. Now, the first thing that you can see is Amazon Linux 2 AMI, right? Here you can see that it has some of the software that they are installed, the Linux kernel it has, right? And the 64-bit x86 version architecture or the RM architecture, right? So two different architectures are also provided with that. Then we have the Mac OS, right? The Mac OS. Then you have the Red Hat. If you are launching a database instance, then you would require something like a Red Hat Enterprise or a SUSE Linux Enterprise. Then we have an Ubuntu and Windows uh, AMIs. So I would be using the Ubuntu. You can go forward with Windows or other environments too, but I would be operating systems too. But you can go forward with Ubuntu server, just like I'm going with it, right? So just you have to click on select. Now once you select, it would provide you information about the type, the family. Now these are T2, T3 families. Again, these families are differentiated on the basis of power and the usage by the user. Now you can see that you have currently selected T2 micro, right? We have selected the T2 micro. Now this is the free tier uh, instance, and I would be using that only right now. And with that, I have the one vCPU, 2.5 gigahertz, 1 GB memory, right? So as you can also see, it has also given you a performance measure that is low to moderate, and which is pretty much good for the Django website since it is very basic website, has very less functionality also. We can work with this. Now what you can do is either review and launch, or if you want to configure your instance and you do have the knowledge for that, go to the next configure instance details. Now you can even increase the number of instances. Like you want to run two instances simultaneously, you can do that. There is an option of launch auto scaling group. So what this does is that once it maps your uh, instance to the usage and sees that if the usage is going above a certain threshold, it would instantly create a new instance and launch that instance to shift the usage to both the instances so that less requirement, uh, so that your instance is not overloaded basically. So that is what auto scaling would do. And then you have the network subnetwork. If you want to set up a particular subnetwork where you want your server to be associated with, you can do that. You have the host name, you have the DNS host name, and there are other roles too, like IAM roles. If you have specified an IAM role, like you want one person or one user to handle maybe these three instances, other user to handle other three instances from the same account, you can instantiate some roles and assign these instances to that, right? Again, this is not really required unless you really want to tailor up your instance, right? You can just go to next, that is add storage. Again, add storage, you can change the volume type. There are different volume types. Again, I won't be going with that, but you can also increase your size. It gives 8 GB of disk space to you. You can increase that. But again, if you're changing these, if you're moving from 2 to 3 and changing the default settings, then there might be charges that AWS would uh, actually charge you up to the services that you're using, right? So you can go forward and see if you want to do that. Then you can even add tags, configure security groups. This is again something we would be doing later on. So if you don't have to change anything, you like the default settings because that is free, I know. But if you like that, you can just go with review and launch. So if you click on review and launch, it would provide you the summary of your instance, right? And then you can just click on launch and it would create a default security group for you, which we can again edit later on. And that would be named again launch wizard 8. And then you can just launch and it would start working. Again, I have already done this, so I would just cancel this, right? But once you click on the launch, it would list out that instance here. So it wouldn't give you the name of the instance. You have to come here and change the name here by clicking this button here, right? So I have my, okay, not this, but I have my this instance for the E. coli virus, right? You can see the T2 micro and some of the, this is the availability zone here and other stuff. But if you scroll down, you can see the details, security groups that are associated with this instance, networking, networking groups that are associated with it, the storage it has, status checks, and monitoring. That is how good your uh, how good your instance is working, how much load it is taking in terms of RAM, in terms of CPU usage, right? All of that can be done, seen through monitoring. But here you can see some other stuff too. That is public IP4 address, private IP4 address, public IPv4 DNS, right? Private IP DNS. So what are DNS and IP addresses? And there's also a VPC ID. What is VPC now? And if you go on to security, you would see that there are some inbound rules, there are some outbound rules. What are those? So before we again configure our instance, we first have to know about these terms and some of the services, right? Now the first thing is the public DNS. Now public DNS, that is domain name system, is a standard by which names used for on the internet are resolved to their corresponding IP addresses, which basically means that let's say that we are going to www dot example dot com, right? I'm going to this URL. Now what happens is that once I uh, hit enter, the server and the browser understand that this is the name of the location. Then it goes into a map where the location is mapped to an IP address. Then it understands this IP address has to be called, which basically means that we have to go to this IP address, and this IP address is associated with this server. So I have to go to this server. And when we type in, let's say, particularly slash home, then the server understands that, oh, he wants the page on the slash home URL. So I would send back those pages to the user. So this is how when we type in google.com, it understands that I have to hit this IP address, and then through that IP address, I have to go to this server, and then the server understands, oh, he wants the dashboard page. So let's just send back the dashboard page to the user, and then the user sees the Google page, right? So that is how it's working. And that is why DNS is required. Again, IPv4 address is required. So now when you instantiate your instance, AWS already, automatically provides you with an public and a private address, right? As you can even see here in the details part, we have the public IPv4 and the private and the DNS. Now this is not instantiated. Why? Or this is not given to you. Why? Because I have not launched my server right now. You can see that it is stopped. So I have to just go to the instance state and just click on start instance. Once I do that, okay, let me just do that. So you can see that it has started the instance, right? And now you can see that I have my public IPv4 address. I have my DNS also with me, right? Now, this takes a little time, but you can see that I've already gotten my address and my DNS, and now the instance is also running. So next thing to know about is the. Let me just go back to security. Yeah, now this is important, and for a lot of reasons, we have to configure these settings for inbound and outbound rules, right? For inbound and both outbound rules. Now, what are inbound rules? So inbound rules in the security group acts as a virtual firewall for your EC2 instance to control the incoming traffic, and similarly for outbound rules, the outgoing traffic. Now, inbound rules control the incoming traffic to your instance, and what you can do is see that when inbound and outbound rules are set, they basically mean that any inbound connection coming to your EC2 instance has to follow these rules, right? Similarly, for the for you to add the inbound rules, it means that these rules have to be specified and all the connections have to comply with these rules. Only then the external application can connect to my server. Now, if you see the inbound rules, I have TCP protocol for both of them, and then I have the port range on 22 and 8000. And I've already specified that Django works on 8000. This means that if Django has to connect to your server for something, then it would have to connect on 8000. Since this is specified here in the inbound rules, the server knows that, yeah, I have an entity that is Django. It wants to connect to me on the 8000 port. Then I will let him do that because that is inside my inbound rules. You see another that is 22. Now 22 port is used to connect remotely connect to your server using SSH, right? Again, this would be clear in the later video where we use those softwares that we have just now installed. Okay, but for now, just remember that there are two port ranges, 22 and 8000 for us right now. So again, this is the outbound rule. Now in outbound rules, you can see that all is specified in port range, which basically means that my server can connect to anybody on the net. Inbound means that any if inbound was set to all, that would mean that anybody can connect to my server. Okay, this is a little confusing, but if you start working with it, you would understand it properly. So this is that, and but one thing to notice is that once you would have instantiated uh, your instance and it would be running, you would see that there's only one rule specified here. So we have to actually add this rule here. So to add this rule, what you have to do is click on security groups. So it would redirect you to the security groups here and the particular security group that is being used by your instance. Here in the inbound rules, you have to click on edit inbound rules. Once you click on that, you have to click on add rule. Then you have to click on custom TCP only and then type in here the port that is 8000. Now I have to click on the down button and say that anywhere IP4, anyone with an IP4 address, my server can connect to that entity, right? So this is what you have to do, and then just click on save changes. Now I already have this, so this would be redundant, so I'm just deleting that. Now just click on save changes. Okay, it's telling me you have not saved, you have not made any changes. Anyways, so once you have done that, you have configured your EC2 instance, but now you have to configure all the files inside your instance so that we can run our project, right? So that is that, and I would be showing you how to do that using the software that we have just downloaded in the next video. Hi guys, so this is the second part of the hosting our application, right? And in this we again would be using the AWS instance and setting that up. So there was one important thing that I missed out in the last part, which was that once you launch your instance, in the end, it would ask you to either create or use an existing uh, key pair, right? That would be a key, secret key kind of thing that it would ask you to either create or use a pre-existing one. So what you have to do is you have to select the RSA type and create a new key for your instance. Now this is a very important thing because without that key, you won't be able to remotely connect to your server. Okay. Again, sorry for that, but this is this was actually important. And I kind of missed this out. But you have to actually download that and keep there at a place where you can access it always. Okay. So let's say that you have launched your instance, you have downloaded your key, and from the last video you have understood all the uh, all the information uh, that is provided by the instance, and I would say that all the terms that would be required by you to understand so that configuring the AWS instance would become easy for you. Okay, so I won't be going on with that now. I would see, I would just suggest you to open up the first software, that is Puttygen. Okay, so there's just a software that is Puttygen, right? So here you can see that you got your Puttygen here. You just have to uh, open up this software. So now what this software does is that it creates a private file for you. So here even you can see that it is asking you to either generate a public private key pair. Now this is what I was talking about, the key pair uh, file that is provided to you by AWS once you have launched your instance, right? So this would be actually of a .pem file, right? This would be a actually .pem file. You can just name it anything. I just named it Coli, right? And saved it into my directory where I have set up the code. Okay, so here what you have to do is it gives you two options, right? Generate a key pair or load an existing one. So you have to actually generate one. Sorry, when we say generate, I mean you first have to load one. So you would just go to your okay, go. Yeah. So you would go here, and now you can see that though the .pem file was present here, it is not showing. That is because it is only searching for .ppk files. So just click on all files, then you can see this. So click on your pem file and click on open. Okay, once you do that, it would. Okay, so let's just do this. So it would see, it is giving you a notice that you have imported a foreign key that would be used to SSH into your remote server, right? Now, the next thing that you have to do is save public key. Okay, this is important. Again, save public key. If you click on that, it would ask you to save your public key. You can just name it anything. Since I've already created one, you can see that it is being shown here. And this is of a PPK uh, type, right? .ppk file. This is a PPK file. So once you have also done this, now you have a, I would say now you have a password kind of thing, right? With the help of which you can connect your machine to a remote server on AWS. Okay, so you have done that. So now the next thing is to actually get connected to the server. So for that, you would run the putty software. Okay, so just open that. Now it is showing you some things, right? The host name or the IP address, port 22. Now, just like I specified in the last video, port 22 is actually for, we actually just have this as an inbound rule, right? Where you are able to SSH, I mean, get connected to your virtual server on AWS or hosted server on AWS, right? So that is happening on port 22, and that is why we do have to include a port 22 TCP connection in our inbound rules. So the host name you can get from the details here, right? You have your instance running right now. So once it is running, it would provide you with the public IPv4 address and public IPv4 DNS. So just copy this, right? Copy this and go back to your application, paste it here, then go to your SSH. Actually, click on this, right? Go to your SSH, then go to authentication. Now, for authentication, it is asking you to insert a private key file for authentication, right? So just click on browse. Once you click on browse, you can just browse into the folder that you have saved your private key, right? That we generated from Putigen. So just uh, select this, click open. Once you do that, it would provide you with the it would tell you that yeah, the private key has been inserted, and it would show you where from where we have inserted that, and just you just have to click open now. So see, and then accept. Now you can see here it is asking you what do you want to log in as. Now by default the user that is created for the AWS instance is Ubuntu itself, right? If you're using the Ubuntu AMI, so just click as Ubuntu and then it would authenticate your public key and log in you. Okay, so once it has logged on, now you can see that we are inside Ubuntu. If I just press ls-a, you can see all the files that are present here, right, in the base directory. So if I just cd dot dot, which is basically going up a directory, you can see that there's home. I'm now into the root directory. Okay. Uh, okay. Now, again, before we just start typing any code to set up the Ubuntu and our application into Ubuntu, the first thing is to get to know about some commands, right? Some commands that would help you in setting up the application, the Django application onto Ubuntu. The first thing is the sudo command. Now, sudo basically is to provide to basically say that I'm the root user, or for Windows I'm the administrator and I have all the accesses to do anything on this machine. So if I let's say sudo uh, okay, let's say I have sudo nano. Okay, let's not do this first. Okay, let's just okay. Uh, sudo nano requirements dot txt. So what has happened now? So basically, let's say that this requirement dot txt was actually a private file, right, which was not accessible to a user. So if I type in sudo nano, the name of the file, then it would give me the access for this file, right? So basically, if I use the analogy of Windows, what is happening here is that let's say there's an administrator and then there's a user. So let's say the user is trying to open some files that are of the administrator. Now it won't let you do that. But if you write the sudo and then the commands, then it would let you access those files, even of the administrators, right? And the next thing actually was to tell you about the nano command. So nano command basically is the pre-built editor for Ubuntu where you just type in the command nano and the name of the file, and it would open up that file so you could, maybe change or append things in the file and then just save it. Okay. Yeah. So these are the two commands. One is the sudo. So sudo actually works with other commands, and then there's the nano. If I just remove the sudo part here, even then it would work. That is because requirements.txt was not actually a secret file or an administrative file, right? So nano is just to open up the editor, and then there's the pwd command. So this tells you in which directory you are currently. Then there was a ls-a command which tells you all the files in that directory, right? Even the hidden ones, right? All of that can would be specified here. Okay, next is mkdir. So this is making a directory. Let's say I'm making a directory dir1, right? So I made a directory here, and to make a directory, we have the command mkdir. So if I just do lsa now, you can see that there's a directory one here, right? Before it was just my site and polls. Now this is directory one here. So let's say that I have to remove this also, right? So let's say that I have to remove this also. So I have to remove this, then I would run the command rmdir, okay, rmdir and the name of the directory. So now if I just do ls, see, the directory was removed from here. Okay, so this is that. But another thing is that here in my in my server, you can actually find the my site folder is there, right? This is already present in your Ubuntu. Uh, in your instance, there won't be any my site folder, at least right now, because I have used my third application, that is WinSCP. Okay, so if you open up the WinSCP, then okay, then yeah. So now it is again giving you an option to log in, but this is for a different kind of purpose, right? So just click on your new site, then again it will ask you for the host name. So okay, again go back to your instance details, then copy the DNS. Okay, do this. Now let it stay as port 22, because again we are having a connection to the instance through the uh, through the key. Okay, so the username, as I told you, is Ubuntu. Now it would ask you for a password. Again, we don't have a password, but we do have a private key, right? So click on advanced, then go to authentication, then go and click here the browse function, then just again select your private key that we created using Putigen. Click on open, click and open, click on login. So it would just log in and ask you for confirmation. Then it would log. Yeah, so now you have logged in. But what we are going to use this software is for transferring our files from our local machine to our virtual server. Okay, so I have my, so just browse through here or just click on, okay, not desktop, but yeah, open directory, right? Open directory or bookmark that. So you can just open your directory where all the code is kept. Since mine is in DNA sequence, so what I do is just click on my site and drag it and drop it here. Okay, so that is what I've done. So it would again ask you if you want to transfer those files, and you just click on OK. Then it would transfer all those files from the local machine to the server. Now you can see my site is present here. Inside my site, I have my project directory, my app directory, manage.py file, requirement.txt, right? All of the files are there. So another thing that you can actually do here is that, let's say I want to make some changes in my code, right? So what would happen is that maybe you have to make your changes in the local machine first, then migrate those changes here. But the cool thing about this is that you can just simply click on settings. It would again open up a basic editor for you. Then you can just directly make changes here. Okay. So as you can see, you can make changes here. Or if you don't want to make changes through this, you can also make changes from here. Just like as I told you, there's a requirement.txt file, right? So let's say I have to make changes in my settings.py file. So what I would do is just go to my directory where the settings.py file is present, then type in nano settings.py. Okay, so it has opened up the file for me, as you can see here, right? So this is how you can even make changes from here or from here. That's your wish. Uh, okay. So one other thing that I would like to highlight is that if let's say that you stop your server, right? You can just stop your server from instance state, stop instance. So if you stop your server and then restart it, then the public address and the public DNS both change, right? So, and another thing that I can show you through is this. So okay, not this. Okay, yeah. So here there's a .env file also, right? So I've, but actually kept this around because I had to explain how the DNS and IP address both change. Okay, but once you have started and uh, set up your application on the server and you have run this application once, then just delete the .env file, because once the env file is run, then all the variables that were specified here goes into the system variables, and the next time those variables are required, then the system provides it. You don't have to use the .env file again and again. Okay, so that is that. But nano.env, now you can see here, uh, before it was 13 233.14.238. Now it is 13.232.237.219. See, both IP address and DNS public ones change each and every time you stop your instance and restart it. Okay, so what I have to do is I have to actually make changes here, right? So you have to actually use the up and down keys. Major downside of this, but then again, this is just the basic one. Okay, and you also have to change the IP address. So click on this, and yeah. So I made the changes, and if you try to simply close the editor, it would say that you haven't saved your changes. You want to save or not? Click on Y, and then again you can just close it. Okay, why it's not closing? Yes, I have done. Okay. Oh, right. Oh, right. Yeah. So it is also asking if I want to keep the name as the previous one, or do you want to make any changes in the name? Press enter. Yeah. Now, if I just run the last command, now you can see all the changes have been also made, right? Uh, so, okay. This is also been completed. Then we just go back into the directory where our requirements.txt file is present. Okay. So before that, there's also another thing that I have created and stored for myself. And what you can also do is that create a, yeah. So I've created just a note, right, where I can have the, yeah, where I can have all my commands that I would need to use. Okay. So what I do is just copy paste it here because I sometimes forget it. So if you run your sudo apt get update and sudo apt get install python pip, so what is happening is that all the Python files are getting updated, and then the pip installer is getting installed, right? So if you just click on this, it would start working on that, right? So this takes a little time, and here you can see that since I've already run this command before, it is telling me that there were no upgrades, and pip 3 is already at the newest version and also installed. Then the next command is pip 3 uh, install requirements.txt. Okay, so what this is doing, it is in, okay, there's a flag that has to be used, dash r, right? So pip3 install dash r requirements.txt. So what this is doing is that all of your dependencies that we have specified are going to be now installed onto your server. Okay, now I'm not creating a virtual environment for this project because we won't be appending new things, or we won't be creating more functionalities that require different kinds of packages which we have not specified in this requirement.txt. But if you think that you would be working more onto this project and adding things, then I also recommend you to create a virtual environment using the VNV package, and then do this process after you have activated your environment. Okay, so if you click on this, sorry, if you just type this and enter it, then all of your requirements would be installed, right? But again, my requirements are already installed on this, so I won't be running this command right now. And okay, another thing is that Python 3 dash version, right? So see, You don't even have to install Python because Python has been already installed onto the your Ubuntu instance, right? And the version is 3.8.10, and that is why with just one command, this one command sudo apt get update and install Python 3 pip, we were able to actually install because Python was already installed on this instance. Okay, so once you have also your requirements.txt file has all the packages and all the packages are also installed. Then the next thing to do would be python 3 manage.py migrate. Now, if you remember, this migrate function or this migrate command was to instantiate each and every table that you have created, and each and every table Django already creates for itself. So all of those tables would be created and stored in this virtual or this server, basically this instance, because what we have done was to have our tables inside our local machine only. So run this command and okay, so it is telling me that there's no migrations to apply and the operations were performed on these apps. Okay, and then the last thing is to start the server. Okay, to start the server, we have to run this command specifically so that Django understands that I have kept the outbound rule as all, which is specified by here, and the port it has to run on. So if you click on this, and it would have some system checks, it would give you some warnings if they are valid. Then what you have to do is go back to your instance, click on the public DNS and paste it here with 8000 port. So as you can see here, we get the page not found again because we haven't created any URL for the base uh, with the base DNS, but with home, we now have a new URL where our page would be loaded. Now again, you can just to check, you can just copy paste it here and just click on submit, and it gives you that for this promoter sequence the person does have E. coli. Okay, so with this, we have completed the project, which was building the model, training the model, and then building our web application that was through Django framework, and lastly, deploying that to the AWS instance, which we were using the EC2 T2 micro instance, right? So with this, we have completed the project, right? So thank you.